we go. Hello everyone, welcome to our talk here today. So imagine for a minute that you're leading platform engineering for an organization where you've got hundreds of product teams who are all depending on your developer platform. So each team needs agility, and they're demanding things like AWS services like databases, caches and queues. So that gives you a little bit of a problem because not every one of those is necessarily going to align neatly with your elastic Kubernetes service clusters. So the question is, how do you provide these services efficiently, securely and at scale whilst keeping your developers' autonomy? Welcome everyone, my name is Richard Ainley. I'm a solutions architect for AWS and I'm joined on stage today by...
I'm the technical product owner for the Kubernetes platform at Fidelity International.
And today we're exploring how platform engineering teams can efficiently provide AWS services alongside their internal developer platform. So in terms of what a developer platform is, just a quick recap. If you imagine for a second how train travel might work without train stations or without platforms. So you'd have to quite vigorously wave for your train to stop, and then you'd have to take a big step up in order to climb aboard your train. And then once on board, the conductor is going to be running up and down the train at every random stop that the train makes, trying to find people, check their tickets, etc. So the train station and the platforms are there to help streamline your journey. Much like with a developer platform, the developer platform's there to help streamline the process of delivering business value. So there's a couple of key properties to what a developer platform provides. Self-service APIs, but really importantly as well, knowledge and support. And all of these things have got to come together to create a compelling product. So this isn't just going to be a product for one team. We know that you're going to be having lots of teams, potentially hundreds of teams using your platform. And they'll be creating lots of different types of applications that depend on all sorts of different AWS services underneath the covers. So in order to think about how we're going to provide these other AWS services alongside your platform, we're going to revisit the benefits and the challenges with developer platforms to see if we can protect the benefits and maybe even advance on those and try and make ground again on the challenges. So the first benefit of a platform is velocity. So via abstractions, we can build in, so developers don't have to focus on infrastructure as code. So they've got the ability to provision the resources without having to write CDK, Terraform, CloudFormation. We can also use those to help with abstractions to build in security and compliance controls and achieve cost optimizations. And that's through creating these sort of standardized patterns that the teams can use. We also achieve cost efficiencies when we alleviate the need for developers, again, to create that infrastructure as code. They're getting time back, but also getting time back to invest in the developing of their platform because they're not managing that infrastructure that the platform team is. So a couple of the challenges, and we'll look back at these as we go through to think about how are we trying to remove some of these challenges. So first of all, the level of abstraction. And it's really important that we get the level of abstraction right, or as right as we can. So too high a level of abstraction and potentially you're going to frustrate users who are already very, very knowledgeable, and too low a level, and you're not going to relieve teams of that cognitive load, which is one of the key benefits of a developer platform. We also don't want to hinder the adoption of our platform wherever we can. So if we've got teams that are used to having other services provided, for them in maybe an on-premises world in a previous platform, we want to, as much as we can, provide those for those teams as well, so we make it easier to adopt our service. Again, to do with that level of abstraction, we want to give the teams the level of abstraction to be able to troubleshoot easy. So that's again that balance between abstraction and the detail needed. And finally, ownership. We need to be really clear about that shared responsibility model so that we don't have any gaps in the ownership of tasks like maintenance and support. So there's typically two types of model that you might go down the route of. So you'll have either a centralized developer platform or potentially a decentralized developer platform. So either way, AWS recommends that you use a multi-account architecture approach with AWS organizations at the heart of that approach. And this really helps isolate and manage the sort of applications and data that you're dealing with. And you can think of this analogy. So on the screen, we've got the picture of a house being architected. So you can think of AWS organizations as the house, and you can think of the floors in the house almost as the organizational units. So you could think of the ground floor maybe as being your social daytime spaces, so one OU, and then you could think of the first floor as the private spaces, bedrooms, etc., which might be another organizational unit. And then you can think of the AWS accounts as the rooms themselves. So this sort of separation benefits isolation. So you're getting a logical separation between AWS accounts, which is going to be great for minimizing the impact of security incidents or misconfigurations. You're also going to benefit from simpler IAM policies potentially, because teams are going to be working with their dedicated accounts. And finally, you're going to distribute the impact of potentially reaching service quotas within accounts, because again, you've got that logical separation. So let's have a quick look at how a decentralized cluster might look like on AWS. So here we've got our workload account. So this is managed by the application teams. It's like an independent unit for that workload. At the top there, we've got the developer platform team, who've got cluster blueprints that they're managing in their GitOps repos. So you might have ML, batch, GenAI type, or general purpose, sorry, type. I swore I wasn't going to mention GenAI in this presentation. Damn it. General purpose type clusters. So they deploy one of these into a workload account. And so here we see our EKS cluster and a VPC within that workload account. So now the application teams have their own GitOps repo through which they can manage their deployments. And we might decide that they need, in this case, it's an S3 bucket and a Neptune database to support just that particular workload. So access of those services from the EKS cluster is done via IAM roles for service accounts or EKS pod identities. And what we'll show on screen now, this is basically another workload, so it's independent of that first workload. So in effect, we've got two EKS clusters, so a decentralized approach. So in this approach, we're getting improved isolation between the workloads. So they're each running their own independent set of infrastructure. That comes at a little bit of a cost. I mean, there's application teams are getting a bit more autonomy, so potentially they can manage a bit of that configuration of the clusters themselves, but at the cost of potentially having numerous sort of control planes for EKS and other infrastructure potentially. So it's slightly increased costs. Also, there's going to be a bit of an operations overhead of managing multiple clusters. So for that developer platform team, they're going to be going to have to tackle like managing updates across decentralized clusters, which isn't easy. And here we have a centralized cluster approach. So in this situation, we've got EKS in a dedicated EKS cluster account, complete with the EKS control plane and also worker nodes. So on the left, we've got the workload account with the AWS services that are being used to support that particular workload. So again, we're going to explore other models of how we might support those AWS services in the later slides. But again, sort of gaining access from our EKS cluster into those workload accounts, we're going to use our IAM roles for service accounts and EKS pod identities, and Resource Access Manager is then going to be used to give us network access between that EKS account and the workload accounts. In reality, you probably won't just have one EKS cluster in this situation. You'll probably have a couple, and they'll be aligned to the software development lifecycle. So potentially, one of the benefits of this architecture is you're getting less cost. So you're sharing control planes for EKS, for example. And provisioning new workloads is also going to be much quicker because you're no longer having to provision a whole new AWS account and EKS cluster in order to bring up a workload. You can just provision a new namespace. There's other benefits as well. So we've got central management of updates and consistent security and compliance controls. But on the other side, again, we've got to consider the challenges around like the blast radius. So potentially configuration changes within your EKS cluster could impact multiple workloads running on that cluster. And also along with that, like in a multi-tenant environment, you'll get complex access management requirements. So we have what we call like a complementary trade-off, zero-sum dynamic. So advantages in one are potential challenges within the other. And there isn't really sort of a right answer for everyone, which is why we're sort of presenting these options. The choice you make really depends on your organization. So the size of your organization, the systems complexity, the operational maturity, and potentially as well the strategic objectives of your organization. So I work with financial services customers, and typically across our financial services customer base, we see them going towards a centralized EKS cluster approach. And when we talk to customers about what services they're provisioning outside of those EKS clusters, typically it will be databases like you'll find on RDS, our relational database service, or Elasticache, or S3 buckets. So taking that example of databases, which are going to be hosted outside of our developer platform, let's think for a moment about the tasks that surround that database. So you've got your backup, restores, scaling, resilience, patching, all of those tasks. So typically, the developer platform team won't be taking responsibility for those. They're focused on providing the EKS platform for many product teams. So in that situation, typically the application team is going to be picking up those responsibilities. But thinking back to the benefits at the start of the presentation, where we don't want to have any gaps in our offering that are going to mean that it might hinder adoption, we see customers potentially starting a database platform team to take up some of those responsibilities. So we can see here, this is a sort of rough RACI model, if you like. Some of those responsibilities have moved away from the application team towards this centralized database platform team. So that ops burden is now hopefully lifted away from the application teams. But this isn't right for every customer, every organization. Again, it's going to be dependent on like the skills within your organization. Maybe the teams already have great sort of database administration, DBA skills, so they don't need this sort of centralized team, but it's something to bear in mind. So we're going to quickly go through 3 different approaches to how we're going to host these AWS services outside of our developer platform, and then we're going to assess them against a number of criteria. So option 1, we've got a business unit centralized database account. So we've got our developer platform on the left-hand side of the screen, and then on the right-hand side, we've got our AWS accounts. So there's an account per business unit in this scenario. So those accounts are just going to contain solely the databases for that particular business unit. So all the workloads that are within that business unit. And these accounts are going to be owned and managed by that database platform team. Option 2, we've got a product team database account approach. So here we're thinking on the left we've got the developer platform, on the right we've got product team accounts, but these are dedicated again to just the databases that are running for that particular product team. And again, the ownership of these accounts and the management of these accounts is going to be that database platform team. And our third option we're calling like an embedded database management approach. You could think of it as a workload account approach. We've got our dedicated workload account for each workload, but the difference here is that we can have other AWS resources deployed into that workload account, so it's not just databases. Another difference, we've got our application teams owning these accounts, but the database platform teams are now managing the databases that are provisioned into these accounts. So we're going to quickly go through our criteria for how we're going to assess each of these options. So on the left, we've got our centralized database account, we've got our product team database account in the middle, and then on the right-hand side, we've got our workload account with embedded database management. So the first thing we're going to consider are the additional AWS accounts that we're going to create. So why are we considering this? Well, what I see within organizations is every additional AWS account brings with it a little bit of extra cost. Typically there's like a fixed cost associated with standard services that get deployed into every AWS account. Along with that you get sort of networking complexity. So we've got obviously a low impact here for the centralized database account, but a high impact potentially for our product team database account. And that's because with that middle approach, we're going to need another account for other AWS services that we want to provision alongside that product. So next we'll have a look at grouping workloads by owner. And this is really important because we want to align ownership and decision making, so we're not getting conflicts within product teams to help with their agility. So where we're aligning sort of the ownership of the account with the product team, we're going to see sort of a lower impact and easier journey. So applying security controls by workload. So security controls are often grouped into buckets, dependent on an application or an application team's profile. So on one end of a spectrum, you might have like cloud native teams who are very experienced implementing most of their controls, and centralized teams are just providing frameworks to follow. On the other end of a spectrum, you might have security and infrastructure teams implementing the majority of the controls. So this might be for teams that have limited cloud maturity, or potentially they're helping host COTS products. So this again, easy when we're in a dedicated account for your workload, more complicated when you're in an account that's got shared tenancy. So the complexity to secure sensitive data. So again, hard in a shared account. As an example, you might have your public marketing website, and that might be the only workload within your organization that can use a public S3 bucket. So you might create an AWS organizational unit that's just for that account with an SCP that says it can use a publicly accessible S3 bucket. And for all other accounts and other OUs, there's a deny on public S3 buckets. Or there's a database example as well. So you might want to restrict all access to an AWS account that contains a database that contains sensitive data. That's a little bit more complicated again in shared tenancy accounts. Even where that tenancy is shared with other resources that are for the same workload, you might have a different team administrating some services and not the databases, for example. So blast radius. So an AWS account is a great, as we've talked about, that logical isolation, a boundary for misconfiguration and security incidents. So again, it can be trickier where you've got shared tenancy to manage that blast radius. There we go. So giving an example, you might have one of your databases is provisioned onto an EC2 instance, and heaven forbid that instance becomes compromised. So you need to think about your containment strategy. So one approach might be to move that AWS account to a suspended OU within AWS organizations. So this means that there's an SCP on it, that just restricts platform and security engineers, or allows security and platform engineers to gain access to understand what's going on, troubleshoot, etc. So this is just one approach. There's a great guide on our website to security instance and response approaches, which I'll share at the end of the presentation in the QR code. It's cost transparency. So as we know, AWS accounts are like the default unit of cost allocation within AWS. So it's easier to see the total cost of an application or a workload within that one account. It's harder in a multi-tenancy account, and that's because, as we know, not every cost can be tagged. So data transfer, for example. So if you're a platform team, like a database platform team, charging back the cost of running a database, it's going to be easier to do the total cost of the database when it's in a dedicated account. So managing rate limits. So as you hopefully know as well, quotas are a defined maximum number of or rate limit of for a whole AWS account. And these quotas come in at the account level, so not necessarily at the instance of a service level. So for example, you might have DynamoDB and you've got read and write capacity units that you want to increase the quota for at the account level. So if you've got multiple DynamoDB tables within your account, it's going to be difficult to, it's not impossible, but it's going to be more challenging to assign that quota increase to a particular table within your DynamoDB database. So again, harder to manage and apply when you're in a shared account. And finally, we want to help application teams, where possible, become product teams. So we want to create a path for them to take ownership of their stack of infrastructure. So this is easier when they're in a dedicated environment. It's not impossible, obviously, in a shared environment. So again, with databases as an example, it's a small migration project, backup, restore to another AWS account, synchronize. Potentially, you can do this without application interruption as well. It's just another consideration. So taking all that into account, I don't want you to walk away thinking Richard definitely said that everyone should do a product team database account approach. That's not quite what I'm saying here. What I'm saying is I think you've got to consider your organization and consider these different aspects as you understand which is the right approach for your organization and your product teams. So I'm going to hand over to Rachel, who's going to talk us through Fidelity International's approach.
Lovely, thanks very much. So Richard's actually done most of the heavy lifting, so all of those lovely architecture diagrams. So I've chosen to keep this relatively architecture light. I'm going to talk through a few principles and then link that back to the examples that Richard has given, and then contextualize that within our organization. But to start, my name is Rachel Wonnacott. I'm the Associate Director for Container Platform Engineering at Fidelity International. You may have heard of us, you may even have a pension with us, but just in case you haven't, we are an international asset manager. We were founded in 1969 and we operate out of 27 countries. At the time of writing, we had 900 billion in assets of other people's money, both for institutions and those of high net worth individuals. We started our cloud journey back in 2013, so some time ago now, and we've built an internal developer platform that aims to service roughly 2,500 developers, which translates to around 650 discrete business applications, but more like 1,400 microservices if you prefer to talk in that kind of architecture. So far, we've looked at lots of examples. Thank you so much, Richard. I'm going to give you one specific example within my organization. Okay, so over my 10 years in platform engineering, I've come to the following conclusion, and that is that if you centralize everything, you create bottlenecks. But on the other hand, if you distribute everything, you create chaos. So I'm not really giving you much of an answer there. It's that age-old seesaw that Richard's already shown you of whether you want to be centralized or decentralized. And the answer, as all consultants will tell you, is it depends. And so for me, the art is in deciding what to centralize. To understand what we're doing at Fidelity, I thought it would be pertinent to give you a little bit of background context on our journey and what we had in place prior to our AWS EKS platform. So in our early forays into public cloud, we went for a decentralized approach. And what that looked like was the automated provisioning of AWS accounts that behaved like private mini data centers for our application workload teams. We did this following the product model and arguably quite a purist approach to DevOps. So we went really hard with the you build it, you own it, you run it. Platform team, out of the loop. And that worked really, really well for some teams. We had great feedback from some teams. But over time, as we built more and more applications, it's become increasingly complex to audit, particularly when teams are doing things in a unique manner. We also had quite a considerable amount of feedback from our application users that actually they don't really care about the infrastructure, and they'd quite like us to abstract more of that away from them. So to me, that sounded like a business profile or a value case for a platform. So that's what we looked at with AWS EKS. So now, once again, I need to decide, is this going to be decentralized or centralized? Richard's talked through a lot of the pros and cons of both of these approaches, but for us, the consistency, the cost efficiencies, and the speed to onboarding far outweighed the negatives, and so we chose to go for a centralized EKS approach. But that's not to say that we ignored any of the challenges, and so we built a really strong foundation as part of our MVP by automating things to handle resource contention, access control, and observability right from day one. So Richard's kind of stolen my thunder a little bit, thanks very much, with the cloud analogy. I'm going to ask you to forget that momentarily and take the new analogy of the cloud. So cloud, or public cloud here, is like a house, but your platform should feel more like a hotel. And so what we acknowledged at this point in our journey was that developers should have a choice. Some people will work better and prefer the autonomy and responsibility of operating in our decentralized accounts, but other people will want to come towards our centralized platform. Now, I'm quite famous internally for saying I really don't like this analogy because it's become so popular. It's quoted back to me on a daily basis, but it received such a great reception at both QCon and KubeCon. I'm going to bring it to you here today. My boss, Dean, sat in the fourth row there, is the originator of this analogy, so thanks very much, Dean. So the reason we used this analogy in the first instance is that we needed a way to articulate what is Kubernetes to senior leadership. So in that part of the analogy, your room was a namespace, and your hotel or your house was going to be your cluster. But we wanted to differentiate the experience of being in the house versus being in the hotel. So public cloud is like a house. You don't get to choose the material of everything, but you can have the images on the walls that you like. You can have the AI to get your AI in onto your fridge if you wanted to. You can paint the walls any color. You can have fur on your sofas. But if there's a storm and the roof comes off, that's going to cost you. You need to find someone to come and fix it, and ultimately it's your responsibility. For us, we wanted our internal developer platform to feel a little bit more like a hotel, where you get less choice, but the service that you receive is reliable, secure, and you have a great experience. You don't need to worry about the plumbing. So when we started to think about these downstream services, things like your databases, your caches, and your queues, which prior to this haven't really been mentioned as either approach to the platform, we wanted to provide that hotel-like experience for these services as well. And to do so, we needed to think about a model for offering distributed services at the back end. If you work in a platform team, you well know there is a threshold or a capacity for how much work you can deliver. And equally, you may well not feel like you have the domain expertise to be offering databases, caching, or queues. So how could we take advantage of other teams in our organization, but still provide a single entry point to our platform? Right, I'm not going to be at all controversial today. I'm going to quote two individuals that you're almost certainly familiar with, the first one being Gregor Hope. I've taken this from the Architect Elevator. If you've not read it, it is fantastic. I also highly recommend Platform Strategy. And the quote that I've taken here says, "A good architecture abstracts complexity. A good platform makes that abstraction useful." So even in a centralized setup, your platform is going to need to service these distributed backend services. So once again, your databases, your caches, and your queues. But they need to be composable self-service products, not just infrastructure primitives. And that's how you're going to leverage scale, particularly in an organization where we have all of these distributed workloads. To do this, I want you to think about doing three things. You're going to hear this first one a lot. That's have a single entry point. So be that a config repository or an API for all of your back-end service requests. Secondly, treat each and every service as a product with individual ownership of the lifecycle. Make sure there is someone that is dedicated to owning that lifecycle. And finally, you want to abstract all those AWS details, things like your VPC, HA, encryption, whatever else, away from your application teams. And you can do this by putting them behind opinionated templates or indeed config schemas. Someone else here that's not very controversial, I hope you're all a fan of Martin Fowler. So what Martin says here is really apt, and that I've taken from is your platform is a product, and that's that the job of a platform team is not to build things that developers could build, but instead to build things developers shouldn't have to build. Now that aligns really nicely with the feedback that we received from our application teams, that they simply don't care that much about the infrastructure and they'd like us to abstract it away from them. How do you do that in this centralized model that we've chosen? Well, you're going to do that with really well-defined interfaces and service level agreements. Developers really need to understand what they get, how to ask for it, but also any guarantees that are associated with that service. To do this, you can define config contracts, much like a data services block you're going to see in some JSON coming up on a current screen. Automate your policy enforcement using lifecycle hooks, so things like pre-approval validation or perhaps your post-deployment monitoring. And finally, be really clear and aligned, which sometimes is difficult in a large organization, on your responsibility boundaries. So things like the platform provisions, but the team owns the schema and the tuning. Okay, finally, I've gone for Gregor again. I really wanted a different person, but this quote is just so nuanced and important to what I have to say. So the best architecture makes complexity disappear, not by hiding it, but by managing it in the right place. Now this is really important because people often think what the platform is doing is removing the cognitive load away completely, which is simply not the case. Cognitive load can't be destroyed, it has to go somewhere. So what we're doing with the platform instead is moving that cognitive load to a team with the relevant domain expertise to offer a service that is far better than if the application teams had to deliver it for themselves. Again, what does that mean in context? Well, first, I'd really like you to use Git for intent and traceability. If you work in a regulated organization like I do, that audit control is really important. Use queues, or actually you could use a controller model as well if you prefer, for ordered and resilient provisioning. And finally, the most important thing is build eventual consistency into your system. Don't try and fake real time. So your GitOps model is declarative, and I'll talk about this quite a lot, but actually not everything should be event-driven, particularly when you have distributed back-end services, which might be stateful, fragile, or ordered. Faking real time will do you more of a disservice than a service. So what does that look like then within our organization? There can actually be a variety of different services delivered via the platform that are owned and managed by a variety of different teams at the back end. And the customer shouldn't really care which team that is or which pipeline is delivering that automation. They should all be presented to the customer driven by that very same declarative config. And what this really allows us to do is standardize, so that consistency that organizations love, the entry point to all of the services, regardless of whether they are owned by the platform team or if they are homed in an entirely different AWS account. And that should be transparent to the user. By having a standardized entry point, every time they request a new service, they're building familiarity and they're building confidence in your service, but also there's no associated cognitive load with figuring out how to receive that service. And within the enterprise, it's really nice to use GitOps because we can enforce a point of review or even approval from security without that platform team needing to be a middleman in between. We've done everything via GitOps, so all of our namespace changes, for example, your quota changes to your namespace is done by customer pull request, but all of our component changes are pulled directly in from the CNCF, also using GitOps. So a small shout out to some of the products that we've used in the community. So we have Kyverno for policy enforcement, we're using Carpenter for scaling, and we have Cilium as our CNI. So we have the AWS EKS backend providing our control plane, but we fleshed out some of those extra requirements in our organization by using some of the Kubernetes ecosystem. But this really is only possible when you have an abstract description of your workload. So I think I've got that example at the bottom, and that's microservice of name X has dependency on database type Postgres and requires, let's say, persistent storage of something like 100 gig. So let's get into an example. And this is the database as a service, which is called the Kubernetes Data Store lovingly within Fidelity. I don't know if we have any of the data services team, but much of the work has been completed by them, and the pipeline is owned by them. I simply look after the platform team. So a huge shout out if they're watching this for the hard work that they have done behind the scenes. As MVP, we offered just one flavor of Amazon RDS because we wanted to do quick iterative cycles. But we deliberately designed that system to scale so that adding more databases in the future would be straightforward, and we're already releasing our second flavor in the form of Postgres. Developers still interact with you guessed it, that single customer config. That's our entry point mechanism I keep mentioning, and it's built on the principle of declarative configuration. And that config is, of course, committed to Git. Every 5 minutes, there's an automated pipeline that is checking that repository to see if any changes have come in. It validates those proposed changes, so things like linting, quota checks, and structural correctness. And then once that's validated and approved, the configuration is merged. A first in, first out, or a FIFO queue connects the configuration to another team's pipeline, thanks data services, and the database is provisioned automatically. There's never any need for the customer to understand where it's provisioned, how it's provisioned, or what that infrastructure looks like. Right now, that automated config check is done by a polling-based mechanism, which we built before we had access to GitHub Actions. So there is an aspiration in the future to potentially move to a more event-driven model using GitHub Actions. But I wanted to call out that for MVP, that polling-based mechanism was actually quite nice because it allowed us to handle our limited resource pool for the dedicated namespace. Okay, so we've got some configuration on screen. Obviously, the information has been obfuscated because we are a regulated industry, but it gives you an example of what you would need to provide. It's dead simple, and hopefully that's quite obvious. It's just the baseline config on the left-hand side that a product owner would need to provide. It's the minimum amount of data that they need to provide to get a namespace. All customers need to tell me is what is their required quota, and what is the role-based access control for their namespace. As you can see, there are no infrastructure skills required. When a database is then needed, the product owner just needs to add in that entry under data services, which if I zoom in, hopefully you can see a little bit better. There we go. And they can specify things like the RDS flavor, the schema, the instance type, etc. But everything else, that provisioning, your IAM, your backups, is fully automated and handled by a platform team somewhere else in the organization. So let's take a little bit of a look at the architecture of that MVP that I mentioned. And again, a huge shout out to the data services team who own this pipeline. This is not my team's. So firstly on the screen, we have a Lambda broker, which is looking for new database requests. And it's doing this by watching the Kubernetes config JSON that we've seen previously that lives in that customer repo. So everything is coming through that single entry point. There's then an SNS topic for the pull requests. And this topic is subscribed to the Lambda, and also optionally a team distribution list if you want to have that live information coming in of the requests from your customers. You then have the Lambda checker, and this is triggered by the SNS topic, and that's going to download the source code from that pull request and triggers a code build job. Code build is going to run various quality checks, so things like linting that I've mentioned, and for audit, it will write the results of all of the tests that is run into the PR, so we can evidence to audit exactly why that configuration has passed. You then have a Lambda deployer for the main release, and this downloads the code from the master branch once it's been merged, and then it triggers a further code build job, which does the fun, heavy lifting of deploying the database. Okay, I'm going to wrap up with 3 principles, and they're all quite simple. There's no person at the bottom, because these are quotes for me, so if you'd like to quote me later, I hope you spell my name right. And the first one is, Git is the UI, the platform is the contract. What we've built isn't just an automation pipeline, it's one that balances developer autonomy with enterprise controls. And to do this, you're going to need that contract. By using declarative config and GitOps and a single entry point, we've made something that feels simple to use, but powerful to operate at scale, which when you have 3,000 developers is really very important. You need to treat your database like any other platform product. It should be declarative. self-service, and policy-driven. And this approach doesn't just work for database, it sets the foundation for how we will deliver all internal services in the future. And finally, I've said this phrase so many times that if it hasn't landed with you, it never will, so I'm going to close on this one. A single entry point is your superpower for scale. If you have a team that eats 2 pizzas, or is 15 people, you will simply never be the domain experts in all of the services that you have to offer, and you simply will not be able to manage the sheer number of pipelines that will come in. The way for your platform team to manage that is a single entry point. So if you take away anything, I hope it's this slide. Back to Richard.
So for me to wrap up, I think the key takeaway for me, there's a lot of information, but the key takeaway is centralize everything. Potentially you're going to have bottlenecks. Distribute everything, and potentially you're going to arrive at chaos. And I think the key word in the summing up is decide what to centralize. So I know AWS having done so many well-architected reviews, a lot of issues that we find are actually where customers don't sort of decide on a particular decision or an architectural decision. It happens and they just fail to make the decision. So I think the key takeaway is to consider these points and decide what is right for your organization. So unlike that sign up there, it's not necessarily just a binary choice either. So it's more like a circuit board. So this is the new signpost for me. So decisions are connected to broader systems, which we've talked about here today. And they can have like cascading effects. So you've got to be conscious of those systems as you make your decisions. So large organizations, we know governance is important. So considering the options up front will strengthen, I think, your long-term governance. So I promised you some QR codes. So I'd recommend taking a photo of those rather than trying to scan every one. It's going to be tricky probably at that range. But on the left, we've got the AWS EKS best practices paper. In the middle, there's the security instance and response guide to containment that I mentioned. And on the right-hand side, there's a really great workshop on platform engineering where you can deploy a developer platform into your AWS environment. Also, please do have a look at Skill Builder. So this will help you gain your EKS badge. So you can achieve this badge by following this free learning path. So this is a free learning path that you can go along to get this EKS badge and share it with your colleagues on your LinkedIn profile. But finally, I just want to say a big thank you. Please do fill out the session survey. Thank you for your time. And yeah, have a great event. Thank you.